Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hommocks Middle School Earth Science Department. Today we're going to be talking about transform plate boundaries and hotspots. The most prominent transform plate boundary we have on the planet is right here in the United States, right in California. Okay, that's going to be the San Andreas Fault. Transform plate boundary just means when two plates slide side by side next to each other, traveling in opposite directions. Your San Andreas Fault is going to be the boundary between the North American plate traveling south and the Pacific plate traveling north. Now, you tend to get extremely strong earthquakes at this type of plate boundary because you have tremendous friction between the two plates grinding against each other, traveling in opposite directions. So your convection cells are going to cause one plate to travel north and the other plate to travel south in this case, with San Andreas Fault in this case right in the middle. And here's an actual photograph of the San Andreas Fault. Okay, the big crack right through the middle of the picture with the North American plate and Pacific plate on either side. So you can take a look at your page 5 tectonic plates chart in your reference table, and you can see that the San Andreas Fault is going to be the most prominent transform plate boundary, but it's not the only one. You also have some subsequent ones in the southwest Indian Ridge. You have a small one off to the south. You also have a few along the Scotia Plate, and you also have one to the south of the Tasman hotspot. So they are prominent on this map, with the San Andreas Fault being the most important. Just in case you get a little bit mixed up, okay, you have your key at the bottom of your map. That leads us to hotspots. Now, hotspots are a funny phenomenon because you tend to get volcanoes in the middle of a plate compared to along a plate boundary. So a plate is going to move over top of a magma pocket or a pool of magma underneath the surface. The magma is going to get forced upward through the crust and a volcano forms. So you tend to have a very active volcano over top of the magma pocket. What happens is the plate moves and the active volcano moves with it. So that volcano becomes inactive as the plate moves off the magma pocket. What happens here is that a new volcano will pop up behind the inactive one now. And this happens over and over and over again. You tend to get a string of volcanoes with the only one that's active is the one that's over top of the magma pocket. That's essentially what a hotspot is. So some of the geologic features tend to get very strong earthquakes due to the fact that you get the quantity of magma traveling up to the surface. You also tend to get some very vibrant lava flows as well. The Hawaiian hotspot tends to be the most widely studied. And you notice that Kauai is about 5 million years old, Oahu is 3 million, Molokai is 1.8 million, Maui is about 1.3 million, and Hawaii is the youngest. Kauai is the oldest and it's the smallest. Hawaii is the largest and it's the youngest. So just by looking at the age of the islands and the size of the islands, you can tell that Hawaii is on the hotspot and the Pacific plate is traveling in a north or northwest direction. That's a classic example of how a hotspot is actually going to be documented with your extinct volcanoes on the plate. So all those volcanoes are extinct with the exception of the active island of Hawaii. Now, Hawaii is not the only hotspot. You have a bunch of them. You have the Tasman, the Easter Island, the Galapagos, the Yellowstone, the Bouvet, the Canary Island, the Iceland, and the St. Helena hotspot. So you notice a lot of those hotspots are found away from plate boundaries, which means that the magma pocket is feeding active volcanoes as the plate moves over top of it. In case you get a little bit mixed up, you have your little symbol right down there in the bottom right hand corner of what a mantle hotspot would look like. So over the course of this chapter, we've been able to find out that your earthquakes and your volcanoes tend to be found in the same regions. We usually find our earthquakes and volcanoes along crustal boundaries. So when you take a look at your tectonic plates chart, most of what you're looking at here is going to be your subduction zones, your divergent boundaries. That's where the majority of your earthquakes and volcanoes are going to be found. With that being said, thank you very much, and we'll talk to you soon. Bye-bye.